Okay, so this is some homework hints for number 4. So we're starting off by using our data from number 3. And so we have this matrix X and vector phi. And we want to say, show that the projection of the mean is the mean of the projection. So projection of mean equals mean of projection. And 2, we want to show that the variance of the data projected to phi is equal to lambda 1, which is the first sorry about that, is phi 1 transpose c phi 1. That's what I want to write down. Okay, good. Okay, so how am I going to do this? Number 1, projection of the mean. I need the mean. So mean column maybe is the mean of x, right? As a, can you still see me there? Mean x, and in my case, I'm summing across, right? So I'm getting mean x2, I believe. This is MATLAB notation. And so just make sure that this is a column, right? Column vector. Good. Now, how do you project the mean? The projection of the mean, this is the scalar projection, right? And so once you have this is your mean, then you just take phi transpose times your mean column. And this should be a scalar, right? It's a scalar. And that should be the same as the mean of the projection. And so on the other hand, we're going to take the projected data, and then find the mean. So we're going to take phi transpose. Now I could take phi transpose times x1, phi transpose times x2, phi transpose times x3, and so on. Or I can just take phi transpose times x, right? And just to double check, that's a 1 by n, or 1 by 3, times a 3 by 4. And so what do we get? 1 by 4. And so that's going to be our scalar data that represents the scalar projection of x onto phi. Okay, and so then you just take the mean of that. So that's going to be the mean, depending on your so if I was writing this in MATLAB, right, this would be phi transpose and regular multiplication, because it's matrix multiplication times your matrix X. Okay, so this is one side of the equation, and this is the other side of the equation. You want to make sure that those two things are the same. Good. So how do you take the variance of the projection? Well, in this case, I would go ahead and mean subtract the data first. So for number 2, oops, I'm running out of space. You're going to be able to see that. Okay, so we want to show that the variance of the data projected to phi is equal to phi 1 transpose c phi 1. Okay, so how do I take the variance of the data projected to phi? Well, this column here, phi transpose x, is the data projected to x1. Data projected to phi. And this is also a 1 by 4 array, right? 1 by 4 array. Good. So you know what? Let's go ahead and mean subtract that matrix before we do this. We already said that you don't really have to, because the mean of the projection is the projection of the mean. But let's go ahead and do that. So let's take xm to be equal to x minus oh yes, we did compute the mean, right? Mean mean call we projected, or we computed in number 1. Okay, and so this would be xm then. And so this now is easy to compute, right? What's the variance now? The variance is going to be the sum of phi transpose x. Oh, I'm mixing my linear algebra notation and my MATLAB notation. Sorry about that. So this is a, I'm going to square those values. That's what I'm trying to say. There we go. If you take the sum of the squares, right, that'll give you the variance. Of course, you could just take the variance too, I guess. That's no fun. Okay, and then for the second part, we just want to check that phi1 transpose C phi1 is the right thing. So we want the covariance matrix. C is the covariance matrix of X. Be sure, by the way, that this is 3 by 3. If it's not, you may have to take the transpose. It depends on how the program is set up. So just make sure that when you're computing this, that you end up with a 3 by 3 matrix. And so then just compute phi1 transpose times C phi. In MATLAB, right, that would be phi transpose times C times phi. Good. All right, and so those two things should be the same. Yeah. I guess if you're using the MATLAB's built-in variance, you don't have to mean subtract because it'll do it automatically for you. Either way, okay, I'm going to stop here since we're already up to 7 minutes, and I'll do a new video for the last 1 or 2 problems.